Namaskar, good morning, good afternoon, wherever you're joining from. I know, Delan, you're joining from Dubai, right, Delan? So,
Hi Abhijit, good morning. Yeah, that's correct.
yeah, okay. So,
Mm.
well, let's give me 1 minute to just do the logistics. I hope my screen is visible to everyone and everyone can hear me.
Yes, Abhijit, I can hear you.
Okay, good, good. 1 minute to go. Yeah. So we are here. We will be starting the sessions exactly on time, respecting everyone's time. So let's get started with today's session. Uh, Today being the first session, we'll have some introduction of the logistics related to this training program. And then tomorrow onwards, we'll straight dive into the session. So just to give a background of this program was created last year. We have been talking about generative AI in the area of specifically bid and proposal management, and then we extended to the entire pursuit management space. And we have been doing it since last couple of 4 years. We have been researching on it, experimenting with it, and last year we launched it as a formal training program as a part of the Samagam initiative. Samagam is, as you all know, our annual event, multi-city event, and we launched it as a part of Samagam. And last year we had around 200 plus 200 around 230 plus participants who joined this program, and there was a lot of positive feedback from the participants. There were also a lot of suggestions on what we can do about it, or what more can we do it to make it more valuable and implementable. Most important was implementable. You put it into use. So based on that, we again worked on the same on this program curriculum, and this year we launched this entire program in a not in a different format, but in the same format, but with a lot of new content and a lot of new approaches towards it. Most importantly is that the transformation which we are seeing in the role in the roles related to bid and proposal management, pre-sales, as well as from pursuit management. So what we did was we included it for the entire, we made it for the entire pursuit management. So that's the reason you will see that it is GenAI for pursuit management, not bid management, not proposal management, not pre-sales, the entire life cycle. So imagine this, like you are facing facing a complex RFP with a tight deadline, multiple stakeholders, fierce competition, and this is a day-to-day scene, normal scene in for every bid manager, every proposal manager, every pursuit manager, and uh, and all this leads to a sort of a chaos, a sort of missing outs, a sort of blame games, and ultimately the entire organization suffers. But imagine what if we can imagine, like uh, not only we could and most of the times this is because of the scarcity of only one thing. And I always keep saying that the biggest resource for a build manager or proposal manager is time. Okay, rest all other resources can be managed. Time is the only resource, if managed right way, can actually lead to a lot of success. It can lead to a lot of productive work. So if you ask me, how do I see generative AI or AI influencing the bidder proposal management or the pursuit management per se, I would say that the biggest influence is that it saves you time. It saves you a lot of time which is spent in doing very non-productive or repetitive tasks. That is the biggest advantage. All other advantages are there, benefits are there, but the biggest benefit, if I see something and if I experience something, that is basically the time. And when you're the biggest resource, time is saved, and not to just by 10% or 20%, maybe by even 40%, 50%. You can imagine what would be the level and what is the value the pursuit manager or the bid manager or the proposal manager can create in the entire proposal cycle. Okay. So that's basically what we are going to explore in this entire program. So welcome to this generative AI for pursuit management program. Here we will explore how generative AI or generative artificial intelligence is transforming the way successful organizations are using to implement them, not only to improve productivity, improve the quality of their proposals, but also the final outcome, impacting the outcome of winning bigger deals, winning larger deals, winning more deals. So by the end of this program, you will be able to understand the fundamentals of generative AI, how it applies specifically to pursuit management. You will master some essential prompt engineering techniques that enhance the every stage of your entire pursuit process, right from your capture strategy to your competitive intelligence, proposal writing, and even writing your executive summaries. And we will see all of that happening. We'll see that happening live on a live RFP, not any sort of a demo or a live RFP. And if you can bring a RFP, I can work on that RFP and show you. Okay, but anyway, that we'll see later. But most important, what you learn is the practical prompt patterns. Okay, and I will explain you what prompt patterns are when we get there. But most important takeaway, and what we have experienced and what we have heard back from our participants, like this year also, the first batch had around 78 participants. What we heard from them was that the prompt patterns, what we discuss during this training programs, what we share with you during this training programs, they are the building blocks. They serve as the building blocks. So basically here you will be learning about those prompt patterns. I will try to give you as many as prompt patterns are there, which can be implementable in case of a pursuit management. And whether you are a bid manager, proposal writer, or a pursuit manager, you will be able to apply them. That is the guarantee which I can take right on this day one, that you will be able to apply. That's because that's the outcome at which we have built this entire program and targeted this entire program. So it's all about the concrete tools which you will use over here, and we'll use multiple tools. And I will show you the different tools. I'll give you multiple tools, and you have to put into practice those tools. Those tools you have to put into practice, and once you put it into practice, you will see that you are having a competitive edge over those who are not using those tools. You will yourself feel that. You will yourself realize, you will yourself feel, and your organization will realize and feel that there is something different when we are using these tools. Okay. So let's be ready. So all ready to just transform. I call it not only transformation, it is revolutionizing the approach to winning business. So let's dive in from here. Oh, voice. Okay. Just a sec, please. Okay. So today we would be discussing more about today's session is going to be little about the technology side of it, the technology or the foundation side of it, the technology foundations or the basics of generative AI and generative AI. But rest and today second half, or the today part of the second half itself, we will start implementing the prompts, writing the prompts, implementing the prompts. But like the analogy says, that it's just not that you know how to drive a car, but you should also be knowing what is there in the car. Okay, what is there under the hood in the car, not to the extent of an automobile engineer or an automobile mechanic, but at least knowing how the car works will help you to select the right car, to repair the car, to whenever there is a breakdown in the mid of a road or somewhere, at least understand or at least diagnose what the problem is. So knowing the underlying basics, at least the basics, will help you in basically understanding what exactly is this technology. I understand not everyone, or maybe not even anyone, it comes from a technology background. We are going with that assumption that nobody is here is having a technology background, is a computer science grad, or is a programmer, or nothing needed. But as I said from the example, that knowing what is the technology behind this tool or this platform which you are using will always help you in making the right decisions and doing the right things. Okay, so that's the reason why we start with the foundations of the generative AI, and not only the generative AI, even the evolution of generative AI, and then we take it forward from there to use generative AI as a tool or as a platform. Okay, so when we move to generative AI, let us first discuss about what exactly is AI. And AI is a term we have been hearing for long. It is not that it's only after ChatGPT or into 2022, November 2022, AI became popular. AI has been there for decades, rather for more than 7-8 decades. AI has been there, right from the World War II, when Alan Turing was using the systems for decoding the messages. That was basically the early stages of AI. And since then, AI has developed, AI has taken different forms and different shapes. But today, when we talk about AI, and more specifically in business, in a business scenario, it is actually a vast ecosystem. It is not only AI has not remained only as a technology. AI has become an entire vast ecosystem, and I will explain you what I mean by an ecosystem here. And the understanding of ecosystem will come when we start looking at the implementation of AI, and the different types of AI, and I will just specifically come to that. So this vast ecosystem is like a huge tree with different branches, and each branch having a specific purpose. Okay, and each branch and this total and the trunk of this tree. So imagine AI like a tree. The trunk of the tree is basically the core concept of AI, and this each branch which is coming out of this tree is actually a different has a specific purpose, is serving a specific purpose, and is actually a stream of AI. And these branches actually solve the different types of problem which AI solves. Okay, till now, if we have seen the AI technology or the computers technology or the information technology, we will see that information technology has been used most in different areas. We have been using AI technologies, information technologies in solving business problems, in solving healthcare problems, in solving traffic management problems, any type of, most of the type of problems, we find that there is a information technology solution. But those solutions were mostly built around data. That there was some data was being provided as an input, some instructions were being provided on how to process that data, and that data used to get converted into some information or insight, and based on that, some information and insight, some decision was taken, some action was taken. That is typically how a IT application used to work. The AI technology, not much different in that sense, but only thing is it went beyond the realms of data. Data here in information technology, also the data, when we talked about, there are different types of data we can talk about. There is structured data, there is unstructured data, image also as a data, the audio also as a data, a video file also as a data. Similarly, in AI also we have got not only the data in a structure, but mostly if you see the IT application, most of the business IT applications were around structured data. In last couple of decades, 2 decades or 3 decades, we can say that unstructured data was being used, images and document images and all those images were being used, but mostly it was around structured data. But AI actually moved outside the realms of the existing formats of data in the IT applications. AI started gathering data from different sources, whether it is from a camera, or whether it is from a sensor, or whether it is even from a satellite, and using that data, using that as a input, started processing that input and taking decisions, creating insights and taking decisions on that. Okay, so if I have to talk about AI, we can say that at a higher basically, if we have to talk about AI in a general sense, we can say that AI is a sort of an umbrella term, and within AI we have got different other branches of AI, and one such branch is machine intelligence. Okay, and the primary purpose of AI, what if we have to say, sorry, if we have to say that what is the primary purpose of AI? The primary purpose of AI is basically to mimic the human way of working, or the human style of working, okay, by using intelligence. Now it is machine intelligence, but similar to that of a human being. Okay, that is basically what we can say is a generic definition of AI. And like as I said, generic AI is a more of an umbrella, and within AI we have got these different branches, and one of these branch is basically machine intelligence. Now machine intelligence basically is something where we allow the machine, or we program the machine in a way, we provide the instructions or the program the machine in a way that it starts mimicking the human thinking, the way human thinks, the way human decipher any sort of information and take decisions. We start the machine starts doing that, and the machine starts doing that without any fatigue, without any bias, or without any limitations. Okay, as long as it has the power, as well as it is it does the chip doesn't break down, it continues working. And that, now again, within this a branch of AI, we basically what we call as if you see the earlier versions of AI. Now look at it like, it is not that AI has been just there, as I said, it has been there in last 2 or 3 decades. AI has been there, and we actually have been using AI. We have been using AI from a very early stage of the AI itself. Okay, and it became so prevalent once these smart speakers like or smart assistants like Alexa and Siri came. Now there is a AI embedded within that application, within that device. Look at your smart watch or wearables. Now there is an AI embedded into it, which is taking some sense, which is taking some inputs from your body, or and then transforming it into some insights, and even taking actions also. Okay, taking actions also. AI was there even in like if you see the robotics, or if you see this autonomous cars, AI is embedded in this also. They are all driven by AI. Okay, but AI is a embedded function in those devices, whether it is Alexa, Echo Dot, or Google's Google what is that, Google's speaker, what you have that, or your AI watch, iWatch, or whatever. AI is embedded into that device. AI is not existing like any other information technology application like SAP, or a database like Oracle, or a operating system like Windows. It is actually embedded within the device. Okay, and that is one form of AI. Now within that form of AI, again there were different and those embedded AIs, those AIs basically, what was the instructions given to them? They were actually a set of rules which were given to them, a set of rules which were understood by that device, that this is, if you see this as if you see the body temperature going above this, then this is the action you need to take. if your camera spots a object, say 10 feet or 20 feet before the car, autonomous car, then you should apply the brake. So that AI within that embedded AI within that particular device or that equipment or that instrument was sensing something or capturing some input. Based on the rules it were given, it was taking an action. And that is how basically AI was working. So if you see here, the AI in a autonomous vehicle and the AI component or the AI application in a smart speaker like Alexa or Siri or Google Home, both are doing the same function. They are taking a sensor, they are taking some input, whether it's your voice or whether it is a camera, whether it's a visual from a camera or a video from somewhere, and then taking an action. Okay, but both were entirely different. One was, you cannot use the technology of Siri or Alexa into a car, into an autonomous car. Okay, so what was happening was, that is basically why we call that type of AI as narrow AI or traditional AI. And this is the type of AI which was existing for has been existing for last at least for last 2 decades. This has been there in the applications. Okay, and this type of AI basically we call there are different names to call it. Some in general, in business terms, we call them as narrow AI or traditional AI. A little more technical, if we say, we can say that this is deductive AI or symbolic AI. Okay, so basically this is you can imagine this like a smart employee who knows the entire HR policies, who knows the entire HR policies. Okay, a smart HR assistant who knows the entire HR policies. But if you place that same HR guy, HR resource in the purchase department or in the finance department, he will not be able to do anything over there. He will not be able, because he doesn't have, because his rules are set as per the HR policies. Okay, as per the HR function. Okay, now this is basically, and he works as per the HR rules which are set there. So that is why we call it a symbolic AI or deductive AI. But in general, most commonly in business, we call it the narrow AI or the traditional AI. Okay, now this is there. Then the second approach is basically, which actually is an entirely different philosophy. That entire philosophy is that you don't have to set the rules for the AI system. Let the AI system itself build its own rules. Now, how does it build its own rules? You provide it the data. You provide it the examples, and let it figure out the patterns from those examples. And once it figures out those patterns, you go on verifying whether it is finding out the right patterns, whether it is understanding the right, it is making the right decisions, it is doing that. You go on, and if it is not, you correct it. You go on correcting it. Like, you give it a random set of images of, say, animals, dogs, cats, other types of mammals, and ask it to identify a cat. But you specify that a cat, this is an example of a cat. Show it 1 image of a cat, 2 images of a cat, 10 images of a cat, and let it figure out what is the commonality between those cats. The cat has a tail. Okay, most of the mammals have a tails, but it says that no, a cat also has ears, and the ears are straight ears. The cat has got whiskers. The cat has got, right? So basically, how it is doing that? It is doing it by vectorizing it the points on that of the image. Okay, let us not get into the technology part of it, but the thing is that it starts recognizing the common pattern between cats. At the same time, it is also recognizing the pattern between other animals and distinguishing is that This is why a cat is different from a dog. This is why a cat is different from a horse. This is why a cat is different from an elephant. So what it is doing is that one way, at one side, it is basically learning what is a cat. At the other side, it is also learning what is not a cat. Okay, what is a cat and what is not a cat. And once that learning, it reaches to a level of maturity, and then when you give it a new set of images with cats, dogs, horses, elephants, it starts recognizing the cats. If it finds that there is if it does it wrong, then you label it and say, because it is not able to distinguish, between maybe a tiger cub and a cat, which may look very similar, then you the human labels the cub, saying that this is actually a tiger cub, not a cat, because this has got these features. So the AI learns from it. This is a technique what we call is machine learning. Okay, and this is exactly the way we also humans learn. If you see our learning pattern, how do we learn something new? We start look at, and the best way of learning, understanding the learning pattern is observing a child. A child who is not exposed to the world, who is not exposed to everything, he learns by observing things. He learns by observing things. He learns by observing faces. He learns by observing things around his surroundings and making inferences out of that. Okay, and started making inferences out of it. And then that is the way it remembers. And next time when it looks at that pattern, it knows that, oh, this is a chocolate, this is a toy, this is a car, because it has seen that those samples, and then it has built those patterns in its mind. And that is basically how even the machine learning works. Okay, and this becomes a new form of basically AI. This is a new form of AI, which is basically machine-led AI, or basically the other one what we used was a symbolic AI. Now this is AI where we are basically saying that here not only you can use AI only by the rules, but the AI can learn by its own patterns, or basically by going through the pattern, its own patterns. Okay, now that is the difference between the machine learning AI. Now, but then it didn't stop over there. The machine learning AI went even deeper, and then we had something what we call as basically deep learning. Now, deep learning is basically where the machine, and also the machine learning is nothing, it is not anything different than an algorithm. The traditional AI also has a set of algorithms. Machine learning has got a set of algorithms. Only thing is that the algorithms work with a different logic. Work with a different logic. In deep learning, the algorithms which were being used were basically based on a different model from the traditional algorithmic models, or the most of these traditional algorithm models, and even the deep learning models are also statistical models, mathematical models. But deep learning model was more based on the neural model, or the way the human mind or the human brain works. Okay, it started mimicking the human brain work, and that is why the word neural model came in. Okay, because the human brain is actually a set of is a bunch or rather millions of neurons connected, interconnected neurons. Okay, and that's how the human brain actually works. Now, when we have this specifically this type of algorithmic model in the deep learning, there was the complexity of the algorithms were increasing. The size of the data which was being used to train these models was increasing. But then there was certain things which were also emerging, new things which were also emerging. And one of the new things which was emerging out of it was basically, and unfortunately, you will be actually surprised to know that this language model, actually language model is not a invention or innovation within the IT system or within the computer science. Language model actually was taken from the linguistics science. In 1930s, some gentlemen started actually doing some research on the pattern of usage of words in the English language. That which were the words which are, because the English language dictionary was growing, there are millions of words, but actually if you see, and this is a normal statistics, that there are actually 60, a average literate person in English, of English, uses around 60,000 words. Now, so this gentleman started forming which are the most commonly used words and in what pattern, which word follows the other word, and in what context does it happen. Okay, so that was the very first, and he started doing it with he was actually researching on the Shakespeare's style of writing. Okay, Shakespeare's style of writing, and from there actually the language model first came. It was not in information technology, and information technology at that in 1930s were, you know, where it was. Okay, but when the AI technology, the narrow AI technology or the traditional AI technology was working in the one of the branches of narrow technology, and this is again 30 years back, is that speech recognition technology. That can computers recognize human speech and understand human speech, and based on that, can we give voice commands and it take actions? So it started from there, and it is from there where basically the language model started coming up. Okay, and that is that branch of AI is known as natural language processing, NLP. You will hear this word very commonly. You will hear this NLP as NLP. The other part, the thing which we talked about, the cameras sensing the objects and taking decisions based on that, that is again a branch of AI, what we call as the computer vision. So computer vision, machine, natural language processing, these are all different branches of AI. Okay, these are all different branches of AI. Now people started exploring what language models can be, or what can be the possibilities within language model. Now, one of the earliest form of language model, if you see, is actually the autocorrection and the auto typing. Now, when you type something on your mobile phone, the system, the mobile, the tool, the tool or the application which you are using, it starts predicting the next word, or starts to complete the word, or starts predicting the next word. And if that is correct, you select that word. So it saves you the time of typing that word. Now, how is it guessing that what is the next word going to be? It is actually using the language model. It is using the language model, the NLP capabilities, and this NLP capability is based on the language model structure. Okay, so that is basically from where the language model came. And when in 2018, Google Minds, the DeepMind, Google research, they came out with that paper of what we call as is a seminal paper in the entire generative AI, what is called as the attention is what you need, is all what you need. Okay, and there the point was, the made was that you don't actually need to understand the entire book or entire chapter to predict the next word. You only need to understand the context of the, if maybe a few lines before and a few lines after, and then based on that you can actually predict the occurrence of the next word in that sentence. Okay, how can you do that? And then they started building that transformer model. It's a very deep and the transformer model is entirely based on the neurological model. Okay, neurological algorithm. So different types of transformer models were built. And actually, we talk about ChatGPT as the first GPT platform, but it's not right. GPT platforms were there, in fact, before ChatGPT also. Like Google had something called Google BERT, not Bard. Bard was the first thing generative AI platform they come. But before that, they had something called BERT, B-E-R-T, BERT. And that is a technology which was being actually used in Google Maps long before even ChatGPT as a company was formed as a company. Okay, auto typing, auto correction, spam detection, all these were actually based on language models. Okay, now what ChatGPT actually, the OpenAI, the company which came out with ChatGPT as a tool, as a platform, was formed in 2016. 2017, 18, they came out with ChatGPT 2.0. ChatGPT 3 was launched in 2022. But before that, GPT was already there. And this word GPT is basically stands for the general purpose transformers, basically that. And this transformer comes from that transformer model which came out of that Google Minds paper. Okay, now we will not go deep into the transformer model, but there are lots of videos, lots of information available on in the YouTube, and specifically Andrej Kaspersky is a lot of videos on that. If you are interested in the technology behind that, you can just go and watch those technology. Fascinating. They are fascinating, mind-blowing technology. Like how things are, but then you can also understand that how these are actually working, how these are working. But what was the difference between these machine learning technology, the narrow AI or the traditional AI, the machine learning technologies and generative technologies? Till now, all these technologies which we were using, all the forms of AI which we were using, were actually only taking some instructions and processing those instructions and taking some decisions and actions. Generative AI was an entirely different game changer for two reasons. One is that it was able to understand human language. Now remember, human language was understood even by the AI system. Natural NLP was there. Okay, NLP, because the Siri and Google, Alexa, these were existing even before ChatGPT came. So they were able to understand the human language and they were able to take actions on that. But that means they were able to draw out the intent of what the user was saying. But not only draw out the intent out of what the user was saying, what the input was, the intent of the input, but also creating the output in a way which was similar to the human language and which was new. The existing applications were only taking inputs and creating some output or creating some actions based on the rules. They were not generating anything new. They were not giving you a new data. It was giving you a data in a transformed way, the same data in a transformed way, or taking the insights in a transformed way. It was not generating new content. Generative AI was the first, and that is exactly what differentiated generative AI from the traditional AI. The biggest difference was that generative AI was able to generate new content which does not exist. Okay, even though that content is based on the existing content, but still it generated that new content. Okay, so that was basically the biggest difference. Okay, now if you see this generative AI, But it was not only limited to generate only that new content and communicate that new content or present that content in a human-like language, in a human-like language in a human-like language. It was also able to do a separate different types of other actions also related to the language. Like it was able to take a large amount of text and summarize it by identifying the key information and the key facts and presenting them in a summarized format for understanding of the user. It was able to take language, take content in one language and use its capabilities, its learning capabilities to translate it into another language. It was able to identify understand not only the intent, but also the emotion behind that intent, the positive emotion, the negative emotion, what we call as the sentiment analysis. It was able to understand the intent of the user and generate a response to in response to that question of the user. That is basically question and answer. Now these were features which were never before there in any of the other AI technologies. Okay, they were there in bits and pieces, but not on one single platform. So that is the reason when ChatGPT, in November 22nd, 2022, when ChatGPT was launched, it became like the most craziest application people would have ever thought of could exist. AI, and the biggest advantage was that till before that, AI was only limited, even within computer science, AI was limited only to those very few nerds or the geeks who could actually understand those mathematical models and do the understand those programming language, deep programming languages, and use those languages and models to create AI-based applications. The common application programmers who were working on .NET or Java or other things, they even didn't dare to get into AI. But then all of a sudden you have a platform like generative AI of ChatGPT, where anyone who is only digitally literate can go in and type and get his things done. That changed the entire model of working in the industry. And that is what became basically the revolution of and that is exactly where the revolution of generative AI started. Okay, so that is the difference, like how generative AI happened. Now, how did that happen? Okay, now, and this is basically what we have discussed also. What is the difference between the narrow AI and the generative AI? Traditional, it basically analyzes and categorizes the existing content. Okay, but generative AI, it creates a brand new content from the scratch. Okay, and specifically it does it based on this capability of natural language processing, which we have also discussed. Like, okay, it can read, it can analyze, it can summarize, it can translate, it can analyze it can understand the intent, it can respond in a way or even a level, the cognitive level of the reader. It can respond based on a cognitive level of the reader. Okay, so that was basically the NLP, which was in action within generative AI. Okay, now how did these AI models get formed, and how exactly do they work? We are not going to go into the work. Basically, as I said, it's nothing but a algorithm which has been trained on massive sets of data. Before that, AI was being trained only on a specific set of data. Like if you had to train it to identify the roads of a particular city, like to an autonomous vehicle, then you are giving it the special data related to that particular city or this type of roads or traffic signals. If it is to detect faces from a computer vision, then you are giving it some other patterns. Okay, so it was being specific, but here the generative AI was trained on every type of data which was available on the internet, and not only limited to the internet. The different types, different sources of information, whether it was the Wikipedia or whether the published books, images on the YouTube, videos on the YouTube, images available on the internet. Based on everything was being used as a data or as a training data for these language models. And that is what made them, why we call them as the large language model. It is not only specific to only a set of data like the images of people or images of animals or data related to books, data related to a specific domain of books, legal data, legal books or medical books. It is humongous set of data coming all from the internet and in different forms and different formats. And based on that, it was trained. And this training basically helped the LLM. Remember, we talked about the machine learning algorithms. Here, actually, it is the deep learning algorithms to understand and identify those patterns. Okay. And those, by understanding those patterns and then correcting by pre-training, that is what we call as a pre-training. But then after pre-training, we do have something called as a reinforcement learning, where we correct. It gives, when it starts acting, the LLM starts telling what exactly it has understood, and we start correcting it by taking human in the loop. It learns from there also. So from there, what came out was what we call as the foundation models. Foundation model means that the training, it has not only been trained with large human sets of data, but it also has been tuned to an extent that the level of accuracy can be more predictable. The level of accuracy is more predictable, that you don't know that okay, what exactly it is going to come out. Whatever it will come out will be somehow more or less closer to the intent of the user. Okay, but then there was other side of it. The other side of it was that, like, and again, that is also like, as I said, that the deep learning models, they are actually based on the way human brain works. Now, as a human brain, we all have, the human has got its own limitations. Like the human brain has its own limitations, and the biggest limitation is its knowledge of things around him. Okay. Now, if I don't know something, but I have some idea of that particular concept or that particular thing, what I will try to do, I will try to guess. I will try to say that I think or I feel that this should be something like this. Like when you're given an object and you're not very able to clearly identify that object, but it looks familiar to you, what do you say? You start relating it with something which is closer to it, right? Which is something little closer to it, or maybe something, and you may say, I'm not sure, but still I think it is like this. The LLM also actually works with that model. That when it is not able to find out the content or prepare the content, have exactly the content what the user's intent is, it tries to build that content based on its experience or its knowledge or something close by to it. But that is not the accurate content. And the bigger challenge is that it tries to do it so confidently and in such a human language that the human who is reading it or who gets that inference, the intent, and from the intent you get the inference. Inference is nothing but the response which you get from the GPT platform. The inference looks so human-like or so believable that you assume that that is true, but actually that is not true. This challenge or constraint or the negative feature of LLMs is called is something what we call as the hallucination. It hallucinates a response which may not be accurate. So that is why it is always suggested that double check the response from the, if that response it has to be something very critical, then it is always better to double check that information if it is generated by a LLM. Okay, so that is where the hallucination things come. But still, and this was very high, and people started controlling. Now, how do you basically eliminate this hallucination? How do you stop the LLM from generating content which may not be actual or factual? There are only two ways to do that. One is train it with more data. Like as we humans, if I don't know something, what is the option for me? The option for me is that I go and learn that thing. Okay, I learn myself. I train myself in understanding that. That is why I learn it. What is the other thing is that? The other thing is that you add, basically in terms of LLM, is basically you add more parameters. Add more parameters means basically in human language it may be that you think more widely. You increase your context of thinking, your cognitive thinking, you increase the window of your cognitive thinking, because then you start looking at a larger model, larger picture. That's why exactly we say that look at the larger picture, because when you look at the larger picture, that point to which is your point of focus, you can see its relation with the larger picture, and then you can see that, okay, what are the things around its context, and when you think what are the things around its context and you learn about that context, your understanding of that concept becomes much more clear. It is the same thing which happens with the LLMs also. LLMs also, either you train it with larger data so that it can identify more patterns, more closer patterns, or you increase the number of parameters. That means you are giving it a much wider understanding of it. Okay, and that is basically where these foundation models have started improving. Now, if you see in the last couple of months, 4, 5, 6 months, last 6 months, LLMs have now started doing the reasoning also. Earlier also there was reasoning, but the reasoning was not that strong. It was more on the generating side. But now LLMs have started becoming the reasoning engines also. And that is also adding new features to the LLM also. But language models were limited only to the text. So what technology started doing is basically including other formats of inputs also and other formats of output. So now the internal working of the algorithm remains not exactly the same, but architecture remains the same. The architecture remains the same. The algorithms may change depending on the type of content. But then the LLMs became more powerful, or by generating not only textual information, text-based information, but also information in forms of audio, video, images. And these platforms, these capabilities, the platforms with these capabilities, they were known as the multimodal models. So the large language models were generally text models. The foundation models were the large language models tuned to a specific purpose, like summarization, translation, all of these features. And these foundation models with capabilities to generate different types of content like text, image, or audio, they became the multimodal models. Okay, so when you hear this multimodal models, you can imagine that it not only generates text-based content, it can also generate images, it can generate videos, it can generate audio, all these things. Okay, now as I said, like this is what also we have discussed, that how does it learn? they consume millions and millions of documents and learn the patterns in these documents. And when they learn the patterns in documents, means not only the pattern of the words or the sentences or the paragraph, but even the word letters also. Okay. And they read that and identify this pattern. And after they identify, I tell you the fine-tuning phase, basically where with a expert feedback, it is given a human guidance that what is right and what is wrong. So you are basically doing a sort of a course correction. And once that course correction, so the pre-training phase is basically the LLM. After the pre-training is over, you have a LLM. After the fine-tuning is over, you have a foundation model. And this foundation model is exactly what when we use ChatGPT or when we use Gemini or Claude, the core of it is actually a foundation model. Okay. And these foundation models, which are able to generate content in not only in text, but also as images, audio, video, they are multimodal models. Okay. Now, again, you can customize your LLM for your business domain. Like now, like LLMs, as I said, when the foundation models or even the language models or the foundation models, they were created. They were trained on the text available on the internet, in the Wikipedia, in the different books and sizes. Now, that is a lot of generic data, and with generic data, there is also a challenge. Another challenge is that the data, everything which is there on internet may not essentially be correct. There's a lot of fake data. And do you know what is the what type of data is maximum on the internet? Anybody, any guess? If you have to define between what type of data is there on the internet, research data or scientific data or literary data, or what type of data you have, maximum, what is the maximum size of the data? What is the maximum type of data which is there on the internet? Actually, it is the marketing data. The data, because most of the companies, the primary reason they use the internet and the internet has been that they have been using it for the first thing they do on the internet is create their website, and it is the marketing data. And marketing data is always biased towards the presenter of the data. So everybody will be trying to say that my product, my feature, my service, my everything is the best. Okay. So there is a lot of bias over there. There is a lot of fake data also. There is a lot of hate data also there. So all that data also has gone into the foundation model. Even though the foundation models, they try to build a lot of guardrails, huge amount of investment goes in building those guardrails, that there is no obscene data, there is no bias data, there is no hatred data, hate related data, no not politically biased data or religiously biased data, but still there is that is there. So obviously, if that data has been used to train it, even though there are guardrails, even though there has been different algorithms and mechanisms have been applied, but still there is always a risk there. Okay, and plus the risk of hallucination. So what do we do when we have to use that LLM for our specific purpose? There are two ways of it. You take the foundation model and then you again train it. You train it based on your company, your organization specific data. Maybe your company's proposals, brochures, policy documents, standard operating procedures, everything what is specific to your organization data. And you restrict the LLM to use only that data for generating its response, or maybe a combination of both. That is what is called as a fine tuning. The other is that you don't actually touch the LLM score, because when you do a fine tuning, remember I talked about the parameters, that is the different layers of the transformer model, because which we actually decides the accuracy of the inference. So when you do a fine tuning, you have to actually change the weights of the parameters. Okay, don't try to get into the weights of the parameters. Is nothing but like tuning. Like you have these consoles, na? The DJ console, if you see, or the audio consoles, if you see, there's different knobs there, right? And you turn those knobs, and the quality of the sound changes, right? These weights in the parameters are like those knobs. You turn those knobs, you change the value of those parameters and the quality. And I will show you something very interesting in that sense, that how the LLM works internally. So you can see that also. So when you change that, it can become creative or it can become factual. Okay. If you change the parameter, there's a parameter called the temperature parameter. Now, if you change the temperature parameter can go from 0 to 2. If it is 0 or something nearing 0, it will be factual. Only if that whatever is there, it will start giving you that. But if you want to make it creative, try to imagine more, then you increase the temperature. If you increase the temperature, say something around 1, 1.5, you will say it. But then there is a risk of hallucination also. So we keep the temperature, the optimal the temperature we say is temperature is at 6. 6 is said to be that, okay, 6 is something, it can be little creative also, but it can be factual also. Okay, we'll see the temperature setting there. When you go into the system prompts, we'll see that. But that is what is fine tuning. When you do the fine tuning of the LM, basically you have to change the parameters of the LM, which is basically very time consuming and cost cost also, because then you are not using the simple normal your CPUs, or you are using those GPUs and the huge compute power and storage power. Fine tuning is costly. So what is the other way? The other way is what we call as the retrieval augmented generation, or what we call as the RAG. This is also a very commonly heard term. Now in RAG, what you do is that you convert all your content, whether it is your emails, your proposals, your business policies, your standard operating models, your brochures, product, everything, into a format which is basically understandable by the LLM. And that is basically, and it is not the standard our content management system, something like that, which we call as the vector databases. So you create a vector database and you store this, convert this data or this unstructured content or structured content into vectors, and you store in that vector database. And you connect that vector database with your LLM. So you have the LLM has got its own content learning, and then you have got the vector database with your company specific learning. Now, when you give a prompt or when you give it an instruction to task or anything, what it does is that it does not directly go to the LLM and take the LLM's training model. Rather, it goes to the vector database, picks up that, tries to find out that particular content from your vector database, takes that content from the vector database, gives it to the LLM and says that now process this data, this content as this intent as per this content. So now you have taken your specific content and given it to LLM as that I don't want you to use all your other content which you have in your training model, but use this, use your translation capability, use your summarization capability, use your all the features of LLM, but on this content. So what, and then give me back the response. So what happens here? You are getting the response based on your company data or your specific business domain data. Okay, that is basically the way you do the personalization or customization of the LLM as per your organization. That is what we call as the retrieval augmented generation, or RAG. RAG is not that costly. Of course, it takes efforts like converting the content in its existing format into a format understandable by the LLM, basically the vectors, the way in converting into the vectorization, what you call vectors, and then using it the vector database with the, but then again now there are tools, and there are and the LLMs are building the RAG features actually within the LLM also, and I will show you that also, that how even, but again there is a limitation there. When you use the RAG capability within a LLM, there's a limitation on the size of the content which you can use. But when you use a RAG database, or a vector database, there is no limit on it. Okay. So now these are now, does it mean that AI does not, everything is good and great in AI? No, there are a lot of challenges with AI also. One is that the hallucination, the accuracy issues. It can confidently state wrong information. Okay. Because it has tried to build that information. Obviously, it has been trained on data, but again, we know that the training data is still a point of time. After that, also there is data which is coming, because the internet is getting updated every second, every microsecond, every millisecond. But when you take the data from the internet, there's a cutoff date that you have taken the data. Although the current LLMs have built-in some feature, have built-in features where it can go and in real time find out the data from the internet. But then data has to be there on the internet. If that data is not there on the internet and that data is specific to your organization, which you have not put on the internet, it will not be able to find. But then there's a traditional outdated knowledge. The risk of outdated knowledge is always there. Again, mathematics, reasoning power in the early LLMs was very low. Now, lot of the capabilities have been added. It has been one of the areas of concern for the AI researchers to increase the capability. But now the mathematical limitation problems to a large extent have been solved. Not to every extent. You cannot still do the spacecraft flight programming or with using a LLM. Okay, you have to still use the normal compute algorithms. Okay, so obviously it requires human oversight. You cannot take human out of the loop, specifically if the information or the content generation is going to be used for decision making. Okay, that is one thing which you also have to understand. Now, this is again a question which comes up very commonly, which basically everybody has asked, like, who owns the AI generated content? Now, legally, this is a very gray area. Okay. Copyright generates that there has to be a human owner. The copyright laws, they say that there has to be human ownership. Okay. But if the tool is generating the content, then is the human who has given that intent to generate that content the owner of the content? And legally, no, because the user has only expressed the intent. It has not generated the content. The content has been generated by the tool. Okay, so that is a legal gray area. Lot of the countries, including India, has come out with certain policies about what is legally generated by AI. Say, suppose you are using LLM to, like what we call, I gave you the example of RAG, like you are using your company's data to create a new content out of your existing data, then you are the owner of that data. Then even if you have used the LLM's processing capabilities, LLM's features, then you are the owner of the data. But if you are using somebody else's content and generating some other new content and claiming that new content to be yours, then you are not the owner of the data, because the content which you used to generate that content was somebody else's content. Somebody else can own that, and that is exactly the challenge which is going between now Disney and Midjourney. Disney has said that Midjourney used Disney's data on the internet to generate its images, to train its LLM. Okay, and there's a billions of fine. And actually, if all these companies which own the copyright data like Disney or Wikipedia, if they go out and sue all these ChatGPT and they prove, then mostly then there will be another upheaval thing happening. Okay. Now, So what is the best practice for protection in this case? Use AI only as a collaborative tool, content generation tool, but always verify and validate the content. Okay. Don't depend only on the AI generated content. Now, let me give you an example here in terms of bid and proposal management. You can use AI to generate a bid plan, okay, or a proposal outline. You can generate AI, you can use AI to write an executive summary also. Now, if you ask the AI to write an executive summary only by giving it a context, and that context is very wide, not very specific, AI will generate the generative AI will generate the content, but it may include certain facts to make it look very authentic. It may include some facts which are not correct, or which may be related to something else which is not actually in your product's feature or your product's related to your product. It may be even a competitor's product feature which you don't have in your product, but it has. But since it finds, the AI finds that no, this is a feature, very important feature, looks very impressive feature, we can use. I will put it here, and you use that in your executive summary. That becomes a risk. But when you create a bid plan or you create a proposal outline, now that is not a content which is going to go out and you are going to use it with your customer. You're not putting it on table. That's where you can actually, that's where the risk lies. Okay. Now, if you are using the executive summary, if you're writing the executive summary using the LLM as a tool, but providing it with the right product features of your product or the features of your service, the differentiators of your service, or maybe even some guidelines to make it specific as per your specific requirements, and it is generating the content, that content you can definitely use. But keeping it wide for the AI to think and generate and then use it, claim that as to be right data and use it, that is going to be the risk. Okay. Now, data privacy considerations. Yes. The enterprise versions of these and all these generative AI platforms, they have got very strong privacy, encryption, and access controls. You can restrict those platforms from using your data to train their data. You can restrict those platforms to store your data on their platforms. They have got their restrictions. The public platforms, the free versions, they are the biggest risk, because the conversations which you are having, they can be used and they are being used to train the LLM. Obviously, that's the reason why they are providing it for free. They're not providing it, they have invested billions. It takes a few hundred of millions only to train a LLM. And they are still giving it you to for free, is only for the reason that they are looking at your behavior, looking at your content, looking at what your intent, and training their models based on that. So when they are in that process of training their models, they are using your content. So their content, you always have the risk there. Okay. So the public platform is always a risk. So what is the way? The way out is that do not use any specific client name. Do not use any, provide any confidential details. Generic things, all the means, like by all means you can use. But if you give specific names, specific details, confidential information, then you are helping the LLM to learn from you. And then next time, because it is working on a probabilistic model. There will be always a probability that it is, when you keep tossing a coin, it is not that every time it will be only head or tail. No, of course, every time it will be head or a tail, but it doesn't mean that there will not be a repetition of 3 heads or 3 tails, or 5 heads or 5 tails. It can happen. It's a probability. So the probability can be there that your content is served back to somebody, your competitor, with the same content. It can be there. So that is the risk. Okay. Okay, now this is again also one of the question which you need to answer is like when to disclose the AI usage. Should you disclose that I am used AI? If your client has asked for it, RFP has asked that whether you have used client AI for usage, you can always give, you should always give that disclosure. Okay, that yes, AI has been used for these purposes, and it has been verified by a human. Okay, we use AI tool, and the AI tool has generated this content, but it has been verified by the by a human. Okay, so there you take the ownership of the content, and of course use AI as a capability that as a productivity tool. We use AI as a productivity tool, and because of using AI, we are saving this much of efforts. And because of these efforts, and this specifically when you are like this question comes up very, not in your proposal, but in your software development or software, that are you using AI? Are you leveraging AI for coding? Like your coding, and what percentage of your code is actually AI generated code? Okay, there it is always better to, if you are using vibe coding or you are using tools for generating basic code, it is always better to give that thing. Okay, and of course it totally depends on your organization's policies, how your organization wants to use it, but you individually can use it in your own ambit, in your own for your own task. You can always use it. Okay, so that's all about it. So some of the terms which we learned about is like tokens. Now token is basically the unit. Like we have bytes in memory, in storage or memory, we measure it in bytes, megabytes, gigabytes. In AI, in generative AI, we measure it in tokens. One token can be one word, or one word can have multiple tokens. Okay, like because you say, like if I take the word, let me take the word example. Like if I take estimate, estimate can be one token. But if you say underestimate, which is again also a new one word, but there are 2 words here, under and estimate, it can actually become 2 tokens. It depends on the tokenization algorithm also. Okay, but generally the norm is 1000 tokens is equal to 750 words. Okay, that is a generic unit thumbs rule we should take. Okay, and tokens define the size of the prompt or the interaction or the conversation which you can have with the GenAI platform. So so the highest number of tokens the platform can support, that means the larger number. Some now tokens can have like millions of tokens, 2 million tokens. 2 million token means an entire book, or not only one book, 2 or 3 books. That much content the AI can take in one conversation. Okay, and every interaction is basically a chain of interactions is actually called as a conversation. And when we talk about LLMs, we can talk about the prompts. This is again the way you give the instruction. The instruction which you give to the LLM, the foundation model or the LLM, that is known as a prompt. And it basically the way you write the prompt, the structure of your prompt. Now, of course, you can write the prompt, and that is the biggest strength of LLMs, that you can write the prompt in a human language, in a natural language, like human, like we speak. But if you write it in a structured way, if you like, again in our in human communication, if I have a clarity in the way I talk, I sequence my words, I sequence my thoughts in a specific structure, it becomes easier for the other person to comprehend. The way I articulate my communication, the other person's comprehension depends on that. Okay. So if I mix up my words, if I mix up my thoughts, the other person will not be able to understand. But if I have my clarity of thoughts, I say that, okay, listen, I want to tell you this because I want you to do this, and I want you to do this because this is how it will help you, and this is how it will help me. Now here my intent and my communication of my or my communication of what I want is clear. So anybody who is hearing that will understand that this is what is to be done and this is what is trying to communicate. So the clarity of the communication of the prompts also decides on the action and the inference, and that is exactly what we call, why we call it as a prompt engineering. We don't call it prompt writing or prompt development, because we don't write a prompt, we engineer a prompt because we want a specific task and a specific inference to be generated out of it. Context window is basically the memory capacity of the AI. How much, like as I said, the context window is of 2000 tokens, 2 million tokens. That means 2 million words the computer can remember, the generative AI system can remember. Okay, that is the number of tokens that can handle. Okay, and the larger the context window, the larger the memory, the more knowledge it has. Okay. Parameters, again when I was explaining, I told you that parameters is basically the learning capacity. The more parameters, the more the learning capacity, the wider number. Okay, and of course the number of parameters, the number of tokens, it affects the size and the capability. So these are the terms. You don't need to understand the technology behind it, but general understanding of these terms like tokens, what is the context window, how many parameters. The larger the number of parameters, the larger the LLM. Okay. The smaller parameters, they are, so we have got small size LLMs also, we have got mid size LLMs also, and we have got large LLMs also. Large LLMs, we can have up to 2 billion, more than 2 billion parameters. And every time you see a new version of a LLM coming in, you will see that there's an increase in the number of parameters as well as in the number of tokens in a context window, which means that now you can take more, you can process more knowledge and you can hold more knowledge. Okay, that means the power of the LLM increases. That is basically the concept. Okay. Multimodal AI, we discussed this multimodal AI, that multimodal AI is something where it is not only the text, but also audio, video, image generation can be done by the same LLM. That is it. And of course, the data quality also we discussed, that the type of the data based on which the LLM has been trained and the guardrails which have been built upon that to correct the incorrect data, the biased data, the hatred data, removal of the bad data, that improves the quality of the inference. And of course, the privacy concern. How can you secure the content but you are providing it? How much, to what level is the content secure? And obviously, can you use synthetic data? Synthetic data means data generated out of data. Okay, and I will explain you, I will show you what is synthetic data when you go later. When you work on this, we check. But that brings us to the end of the first session. I hope that has been, if we have any questions, we can discuss it now, or we can take a 5-minute small break. Anybody has got any questions related to what we discussed? Anyone? Can you just open up? Okay, fine. Then what we can do is that we'll take a 5-minute break over here, and then now we will straight away jump into looking into how to work with prompts. This was the, till now, this was the more of the foundation and the technical side of it. After this, it is only prompts and only related to bid and proposal management, what our day in, day out, what we use day in and day out. Okay, so till that time, it was just only the laying the foundations. Now after this, we will go it. Wherever required, we will talk about it, but no more technology after this. Okay. Good, then we will take a 5-minute break and we'll come back to right now. It is 10:24, 10:30 we will be here. Okay, I'm back. I hope everybody is back here. So let me go and share my screen. Okay. Okay. So let us start with prompt. Prompt, as I said, like prompt is the way how you give your instructions to the LLM, whatever LLM you are using. Okay, whichever LLM, whichever generative AI tool which you are using, and I will be using generative AI, LLM, foundation model interchangeably, but more or less, I mean, is the same thing. Okay, so whatever LLM you are using, whether it is a ChatGPT or whether it is Gemini or whether it's Claude or whatever tools, and there are a lot of DeepSeek and Llama. So many tools are there. Whichever tool you use, the way you communicate with it is basically called as a prompt. Okay, so the prompt is how you express your intent. You express your intent to the LLM that, hey LLM, this is what I want from you. I want you to summarize this text. I want you to answer this question. I want you to translate this content. I want you to generate a video, whatever you do. That is basically a prompt. But a prompt is not just like giving, like communicating it, like, of course, we say that the strength of the generative AI is that it understands human language, it interprets human language, it responds back in a human-like language. But then again, as I was explaining you, that in human language also there are certain rules of communication. There are certain best practices of communication, like clarity, comprehensiveness, okay, being clear in what your intent is, being concise. These are all the 6 C's or 5 C's or 6 C's of communication, what we talk. So most of them or similar rules actually apply in your prompt writing also. Then, like if you look at human communication, and specifically when it is a content what we are reading, or even when you're talking also, like the conversation between two friends and the conversation between a boss and an employee, a manager and an employee, and the conversation between a newsreader and the audience or the viewers of the news, they are all conversations. They are all communicating. But there is a difference, right? The difference between the way the two friends talk to each other, or two friends communicate, and even two friends communicate, even if you see the context, two friends when they're face to face and they're communicating, the communicating style will be different. If they're communicating over a phone, the communicating style will be different. If they are communicating maybe while traveling, one guy is traveling, another guy, if the one guy is in office and in front of other people around, the communication will be different, right? The style, the tone, the communication will be different. So the style of communication also depends on the context, the context where you are in. Similarly, in prompt engineering, when you are giving a prompt, if you are giving it that same context, so basically what I am trying to say is that the context is as important as the content and the intent. So remember between these things: intent, content, context. These three concepts should be very clear. Intent is what you want to do, what you want the LLM to do, what you are expecting out of it. Content is basically what you are telling it, what you are transferring, the communicating. And context is the scenario or the situation in which you are doing it. Okay, that is basically the intent, content, and context. These three concepts should be very clear when you are using prompt engineering. So a well-crafted prompt, actually, now you can give it a direct, and I will show you the result. I will show you the impact of it. When you craft a prompt following a specific structure, you will see 5 times it says the effect is 5x, like the impact is 5x, the better quality of results. If you have specificity, like if you give it if you use very specific words, okay, detailed, and you give it the relevant content and detailed content, okay, your quality of your inference or the content, inference is basically the response given by the LLM. The quality of the inference is 200 times better. Okay, and if you give the prompt examples, if you provide the prompt the examples of how you want the content to be, or what you have 3 times better or 3 times better the content. Okay, so this is basically, that's the reason why we call it prompt engineering and not prompt writing or prompt development. Okay, because prompt engineering gives you that capability to structure your prompt in such a way that you get the best results, most impactful results, or the correct results out of your prompt. Okay, now there are different levels of prompt writing or prompt engineering. What we will talk today is the basic one, the very basic. Okay, I'm sure most of you are already using generative AI in some form or the other without any specific structure or specific way, or maybe you have devised your own structure by your learning, some level of learning, and you see that, okay, if I write the prompt in this way, it works better, it gives me more accurate or more tuned content, aligned content as per my intent. Okay, your purpose is that the content which you get is aligned as per your purpose, as per your intent. Okay, so you do it by setting the context, that is defining what the role, situation, and audience, and I will explain that. You specify the output, like how do you want the output, you give the context, that is provide the background. And one thing, and the most important thing, if you have to remember in anything about prompt writing or prompt engineering, is that prompt engineering is a iterative and incremental approach. There cannot be that you write the prompt in the very first go and you will get the best result. The more you iterate, the more you increment, you provide more context, the better your results will get. Okay, so never believe that the first result which you got from the prompt, like generally we say that the first gut feel we get is always mostly the right gut, is the mostly the right. Whenever in doubt, use the first gut feel which you get. Okay, but in case of prompt, that is not true. In case of prompt, the more you increment and the more you iterate and more you increment. Increment means provide it the more context, provide it more examples, provide it more specificity, then your prompt inference quality improves. Okay, now let us go and see some tools in use. Okay, so I will use 3 different tools, or basically I will show you 3 different tools, but mostly we will be using ChatGPT because that has got a very simple interface. Although no, that's not actually right also say that, because yeah, Gemini also has got a good interface and Claude also has got. Okay, so you see ChatGPT, this is the ChatGPT interface. So we will be using the chat interface. Maybe if I have time, I can show you the other interfaces also, like the playground interface, but that is more from the technology perspective. For more or less for anybody who is using for its only specifically for business purpose, will be using the ChatGPT, but I will show you others. So this is the ChatGPT model here. You can see. Then we have the Claude here. This is the Google Gemini. Again, the same type of model, same thing, same you can see here, same model, and then the Claude. So most of them have got this one text box. Again, thanks to Google, the Google search bar. So similar, you have a search bar here and you do it for you. Okay. Now, then we have Perplexity. Perplexity, again, Perplexity is also this one, if you can see here. If you go to ChatGPT here, on the ChatGPT on the left hand side, you have got this menu over here. You can always start a new chat from here. You can select your chat model. Okay, like this chat model 4o. I select 4o for a reason that it has got a very strong reasoning power. Okay, but I can select any other model. O3 advanced reasoning, O4 mini is fine. Then there are many more models. 4.5, this is good for reasoning. This quick GPU 4.1, 4.1 mini, faster. So you can use your different models. And as I said, the models are dependent on two things. One is the token size, another is the parameters. Okay, and these token size and parameters define which model is good for what. Like they are very specifically saying that you can see here, specifically saying that 4o is great for most of the tasks because it's a generic model, but O3 uses advanced reasoning. So this is, don't use it if you want to only do a summarization or text translation. Use 4o because it is generic. But if you want to do a very mathematical or reasoning based task, then use O3 model. So these models define what type of which model you should use for what purpose. Okay, and you can just go and click over here. You can see which it takes you a detailed how do you do a model selector. Okay, the most powerful reasoning model O3, 4.5, and of course the models are also important because the number of tokens the model uses. Reasoning models will always use larger number of tokens, higher number of tokens. And as I said, token is the currency of the LLMs. The number of tokens you use, the number of money you pay. Okay. Now, when you're using this LLM as an interface, there also, like, of course, this is a subscription based. This is a monthly subscription that $20 you pay $20 per month and you use it as much as you can. But still, there is a limitation. There's a limitation on the number of the O mini model you can use or the reasoning model you can use. Why? Because the more the reasoning capability, the more the number of parameters, the more the context window, the higher number of compute it will require. Higher number of compute it will require means higher number of GPUs will be needed. Higher power of GPUs will be needed. Higher power of GPUs needed means higher cost, bigger cost. So using smaller models, using models with lesser number of tokens, lesser number of parameters will always be cheaper. But then there is a compromise trade-off between the accuracy and the and of course the capability of the feature also. So that is how you do the model selection. Okay, so you can do that here. You can have a sidebar over here so you can see all your previous conversation. So everything here what you see is a conversation. Okay, and in this conversation we can do this, and then you can have is basically you can have a library. Oh, you can actually store your lot of your content in your library also, and whatever you have created in your past basically also can be stored over here. Okay, so you can have your library over here in the chat. Okay, so these are like the images which we have created from using ChatGPT. Yeah, you can search in your chats. You can go and search for your previous chats and all of the things. Yeah. Okay. So let us go to a new chat and start. And then you have got other like Codex is another platform within OpenAI where you can generate code. Sora is the video generation capability you can use with it. GPTs are basically again they are not agents, but they are autonomous. You can call them as like a bot. So if there is a repetitive task you want to execute again and again, you don't need to write the prompt again and again. you can you can create a GPT and you can store that GPT, and you can, whenever you like to write that prompt, you can run that GPT and it will create it. Okay. So these are the GPTs which I have created for myself. But anyway, let us first get into the structure of a prompt. Okay. Now, the very first thing what we comes to our mind is that if I have to get a task done, I have to tell the ChatGPT what I need to do, so what I want it from me. So I can say, suppose as a bid manager, I know that the first thing I need to create is a bid plan. Okay. So I can just simply go and say, generate a common, like if you like you are talking to your bid coordinator as a bid manager and you want to create a bid plan, you can generate a create a bid plan. Okay. Now, does it say that okay, no, I cannot create a bid plan till you tell me for which RFP it has to be created, what is the start date, what is the end date, what is the, it will generate a bid plan. But is that bid plan enough? So it is saying that, okay, it is using its brain and saying that, okay, client insert name, opportunity, give it, explain this, bid type, due date, objectives of the bid. Oh, whatever. Shit, I clicked it. So, create a bid. Now, let me tell you also one thing is that you will see this this step-by-step approach. When you create this, you may not see this step-by-step approach, and this type of the response may not be in this slide. The reason for that is that I have customized my settings. You can also customize your settings within ChatGPT. Okay. Now you can customize your settings by going over here, and you go to settings over here, and in settings you can go personalization. When you go to personalization, you can give it some custom instructions over here. I have given it some custom instructions, and you see the custom instructions. I have given what is your call you ChatGPT, what do you do? I have given it some list of constructions, and I'll talk about them when I will describe it. Okay. But what traits I actually, so I can personalize, I can give it some instructions, and I can personalize the entire response of the ChatGPT. So whatever I give it, now I have given it that you should not use these words. Okay. You should not use these words. Okay. Because these are the very frequently used Gen AI words. Anywhere where you see this word unlock, unleash, you will understand that this is a generative AI work. This content is generative. If I have to use avoid that, I will restrict it. So basically I can do it, do that here. Okay. And so this is basically what we call as the personalization. I can also have the data connectors over here. Connectors means, this is again an example I was giving you, that I can connect it to SharePoint, I can connect it to Google Drive, I can connect it, like I have my connected to Google Drive, I have connected to my SharePoint. Okay. And I can connect it to my Outlook email, and all those things. Okay. So these are the integrations which you can do. Okay. Now these are available only in the paid version. The free version does not have this. Okay. But there's one thing which you can always do is basically the security. Okay. Now security is basically, one is that nobody else uses your ChatGPT session to create some content. So that is basically one security content. But the most important is the data control. In the data control, you can always archive your chats, share your chat links. Basically, you can say that, okay, don't use my chat links over here. Okay. Improve model for everyone. Improve model for everyone means that use my training data. But I have said it off over here. Allow your ChatGPT content to be used and trained, which means makes ChatGPT better for you and everyone. Now it's giving you a very, very honest reason that why you should share your data. Because when you share your data, it's like a very, what do you call that, humble way of saying that, okay, give me your data, I will train my system so that it does that. But if I switch it off, then I am basically, we take steps to protect your privacy. So, but if I switch it off, it means that my data, whichever I am using here, will not be used by OpenAI for training its model. So it is not going in there. Okay. So these are some of the controls which you can take over here. So look over here, general control here. Mostly the theme is a language, what you use, spoken language. I use is Hindi. Auto detect, the language I play is A, so I can do that. So these are the most. But again, as I coming back, so if I give it only a plan, a statement, say, but only thing is that I have given it a instruction over there, so that's why it is following that it is taking a step-by-step approach. It is clarifying the context, it is defining the objective and the strategy, and then whatever steps it is telling me. So by knowing, by giving that, what is happening is that I know how the LLM is actually working, and if I see there is something which is wrong over here, I can go and ask it to change this particular step over here and recreate it. Okay. Now, what I see is that it has done created a bid plan, which is fairly good, but I actually want the bid plan specifically with a bid calendar for a day from starting from today and ending on maybe 30th of July, and also I want it in a sort of a day planner, in a day planner format. Okay. So now these are my requirements. How do I specify my requirements to the prompt? There are different ways of doing that, and that we call as the prompt techniques or the prompt patterns or the prompt templates, whatever you get. One of the very common prompt pattern is basically, and we have, this is known also, and you will see the logical reason behind it also, that always tell the LLM to take a specific role which has the skills of the task which has the skills to execute the task which you want the LLM to do. Now, in our case of creating a bid plan, which is the task, which is the role which has got the best skill to do that? Of course, it is the bid manager. So we will give it the role of a bid manager. Now, and I'll explain you what happens when you actually give it the role. Now, earlier we didn't give it any bid manager. I only gave it a straightforward, create a bid plan. And it has given me a bid plan, which is very generic in nature, but I want to be very specific. So I am saying it, I'm giving it a role. So, and the best way to give it a role are, there are two things you can do is always, or two ways to start. One is imagine, another is act. Say, I say, imagine you are expert bid manager. Okay. But I am creating a bid plan. But the bid plan, can every bid manager create the same quality of bid plan? The answer may be no. Any bid manager who has got a project management experience or a PMO experience will always create a better bid plan than anybody else, anyone else who doesn't have a PMO experience or a project management experience. So I will again, not only I am giving it a role, but I am also adding another exemplar to the role. Okay, that you are, you have decades of project management experience. Okay. The other thing what I want to do also is, as I said, there are two things which are very important. One is three things which are very important. One is the intent, another is the context, and the third is the content. The intent, what is the intent over here for me? The intent over here is that I want to create a bid plan which should be very, which should help me in managing the entire bid like a project. Okay. And so so my intent is that I am to create a bid. So I will specify your task is to generate a bid plan. Okay. But again, generating a bid plan, I had given it also earlier also, and it has followed it also. But now I want to be specific. specificity. And I have to give, to be specific, I have to give it the context. Now I can give it a context either separately or is a part of the intent also. I want to generate a bid plan for a government bid, because I know that government bids, there are a lot of compliance requirements, there are a lot of processes to be followed, certificates to be given. So I want to be very specific for a government bid to be, and also I want to say that, okay, submitted or to be submitted by to be submitted on or before 30th of July. 30th of July. Okay. Now I have given it some specific, I have been specificity, as well as I have given him some context. The context is for a government bid. And also given it a context that it has to be submitted before 30th of July. But I also want it in a specific format. Like I want it in a day planner format. Or I want it in a week-wise format. So that I know that every week what are the tasks I have. And I want to also know who are the which are the roles and responsible people. So I want it in a sort of an Excel sheet or a table or something. Now this is what? This is your output format. So you are telling that I don't only want the content, but I want the content in a specific format also. So I will say I want you, or you can even say like you will create the bid plan as a weekly planner in a table format. Okay. Now I am only telling it to create it in a table format. I am not specifying what should be the columns in the table. I can even specify the columns in the table also. Let me just simply give it like this and see what comes. Okay. So it is giving you a step-by-step approach. It is working backwards from the deadline. It is dividing into weekly work streams. It is including governance and review points. It is including capture internal, external dependencies. It is formatting as a clear table. Now, earlier, what it did was, it did the same thing, but it did not do all these things. Okay. Okay. So it created a very generic format. But now you see, it is giving me a very specific format in a table format. Week 1, they starting from today to this. These are the key activities. These are the owners. These are the outputs, and the other. And I can directly copy it from here into my Word document or whatever I can, and I can see week 3, week 4, week 5, week 6. Okay. This planner assumes a standard 5-week timeline with 1 buffer week. Let me know if you would like to adapt it for a different then or convert it into a Gantt format. It is not only giving you a table format, but it is also asking you, do you want it in a Gantt format? Okay. Now here it did not ask me anything else. Here it says that, oh, hey, this is a generator. Sorry. The first prompt when I gave, it just simply gave me this and said that this is, let me know a specific bid type you want to, like a tailored version of this plan. But when I gave it a specific format and a specific whatever exactly I want to give, it created it in that format. See, this is the difference between what we did here. The first prompt what we wrote was, this was basically what we call as a ad hoc prompting. The first prompt which I gave, okay, create a bid plan. They do this. This is what we call as a structured prompting. Okay, where you not only specify your intent, but you also specify the role, provide it the context, and provide it the format of the output. But this is also what we call as a structured prompting, but a very basic, simple structured prompting. Tomorrow onwards, when we move into the other types of prompts, you will see a much more different way of prompting. But today, today the objective was that you understand the difference between a ad hoc prompt and a structured prompt. The quality of the inference which you, what has changed here is the quality of the inference. How can you make generative AI work for you? So your intent should not be that generative AI should do the work for you, should do your work. Your intent should not ever be, because you will put yourself at risk if you say ask generative AI to do your work. Rather, you have to use generative AI. You have to make generative AI work for you. Think of generative AI as the most smartest, intelligent assistant you have. Use it as an assistant. Don't let it be your replace your role. Okay. So that is why you need to do it this way. Now you can, but does it mean that you can do it like this? That I have given a bid manager and actually what it does. Okay, to explain it, I'll show you another, and maybe this is the last. Okay, we have already learned. Okay, this will be the last prompt I will show you today, and I will show it in an entirely different context. Let us go out of the bid and proposal and pursuit management context. Okay, let us use it for some other context. Okay, imagine I will like imagine I will give it a funny character. Who is a funny character I can remember? Imagine you are Circuit from the movie Munna Bhai. Okay, I'm giving it a role and I'm giving a circuit. Okay, from the movie Munna Bhai MBBS. I will ask you a question and you will respond to me like circuit. You respond to me like circuit. Respond to me in a let me be a little specific and style like circuit. Okay, let's see what happens, and I will explain you why I have written this prompt. I hope everybody can see my screen. You can open up your microphone and give it.
Yes, I can see your screen.
Okay, so it is saying bilkul bhai aap pucho. Now it has come back to Hindi. I didn't tell it to respond in Hindi. Okay, but it has said that okay, circuit is Hindi. Aap pucho circuit full josh mein. See the language, see the tone, that Bollywood Mumbai tone. एक स्टाइल में एकदम जवाब मिलेगा, एकदम झकास बोलो तो रेडी है बॉस. Just think, how did it do that? आप बताओ क्या सवाल है? Now it is asking me in Hindi. Okay, I'm going to talk to it in English. Okay, I'm not going to tell it in Hindi. What question should I ask? Let me ask a question. Okay, what is the reason Trump lies? Read the content. Now, How do you think LLM is working here? Anybody has got any clue? If you read this content, you will see that we will feel that, okay, this is exactly the content which your circuit would have said, like if you was asked this question, right? Now, how did it do that? How is it that here, when you told it that imagine you are a bid manager and you are a project manager, it exactly made a plan like a project manager. It exactly thought like a project manager and created this project plan like a project manager. In the same conversation, you are telling it to be a circuit which is an entirely different character, entirely different role, and it has changed the context. Why was that? Anybody, any thought, anybody, any clue? This is not magic. It is logic.
It is how you write a prompt. It is like how you write a prompt.
The
No,
parameter.
that is right, Harish. I agree that this is how I have given it, because I have told it to behave like circuit, so it is behaving like circuit. I have told it to behave like a project manager, so it is like a project manager. But how does it know what is the project manager's behavior, and how does it know what's the style in which circuit talks?
It has picked up the data from the internet, and all these data are readily available.
Yes, exactly.
That's
What it does is that this circuit and project manager, these are nothing but cues which are being given to the LLM. The cues are going to the LLM, to the transformer within the LLM, and what it is doing, it is now narrowing all the content related to a project manager or to circuit. It is bringing all those petabytes of data. From those petabytes of data, it is extracting circuit related kitna. But now the circuit can be an electronic circuit. How did it know it is a circuit related to Munna? Because I mentioned Munna Bhai MBBS. If I would not mention Munna Bhai MBBS, there would have, the context would have been larger. So what I am trying to do is I am narrowing the context. The point why I am trying to explain this is that the more you narrow down your context, your more specificity you produce, your inference will be the much better, much larger. Because now you're using the compute and you are using the inference only on that limited set. Okay, so that is why it is important that you provide it a role, you provide it the context as much, and provide the example, and provide it the format in which you want the output, and the more better. Ultimately, what is your objective? Your objective is to get a accurate, better, factual content from the LMS. That's actually what you have to do, what you want to do. So that is the difference between prompting in ad hoc prompting and structured prompting. Structured prompting, you are making it specific. You're bringing it focused. You're doing a focus. And obviously, you're getting the content in that format. Is that clear to everyone?
Yes.
Okay, good. I think we can stop. Oh, anybody has got any questions? Any questions? We can take the questions now, and or we can stop here and stop sharing. Okay, we can. So anybody has got any questions? Anything? Any